Now, instead of writing it separately in the form of internal noise power, I'll just go a little bit towards right. I will now define new PNI. I'll define PNI total. PNI total will be nothing but the original value of PNI, which is 1 plus zero point 0.5. Now let us see what is this 0.5. So now new PNI total becomes 1.5 watt. I will now calculate PNO using the formula that we have written. PNO, I'm saying, will be G into PNI total. So PNO will be G into PNI total. G is nothing but 5 into PNI total has come out to be 1.5. Now if you do 5 into 1.5, we get the value of 7.5 watts, which is exactly same as the value that we have obtained before. So what are we doing it? Instead of mentioning internal noise power of the amplifier separately, we are taking its effect on the input of the amplifier. You can see I'm not taking 2.5 directly on the input. I'm taking 0.5 on the input because 0.5 will be multiplied by the power gain of 5 and will become 2.5, which will be added by the amplifier otherwise. So to conclude, we have assumed amplifier to be noiseless now, and its internal noise is considered in the form of PNI total. So PNI total can be written as, in simple words, the total output noise power which the amplifier generates divided by its power gain G. However, we have the expression for noise factor F, which is PSI upon PNI into PNO upon PSO, and this was written in one of the previous clips as PNO upon G times PNI. Therefore, my PNI from this expression, if I just write down PNI, it becomes PNI goes on the other side, PNO upon this F comes here, it becomes PNO upon FG. And therefore, this is my PNI. This is the original input noise power that was present. If I want to write, I can also write PNO. PNO will nothing but be FG into PNI. And PNI, if we assume it to be thermal noise power, then we know that PNI is equal to KTB. Therefore, PNO becomes FG into KTB, where KTB have their usual definitions. And therefore, my PNI total becomes PNO upon G. PNO is this whole thing, FG KTB, and if you divide this with G, you can see G will cancel out, and therefore PNI total will become FKTB. So that means I can consider an amplifier and simply say that at the input of this amplifier there is some signal power present, and the noise present is not anymore PNI, it's PNI total. The output signal power PSO will be very much equal to G times PSI, and now I can say that the output noise power will also be G times PNI total, and this will be exactly same as G into PNI, which is the original noise power, plus internal noise power of the amplifier. So internal noise power of the amplifier is already considered in the form of PNI total, and hence I can say this amplifier becomes noiseless. That means it will not add any noise anymore. It is just that we are calling it noiseless because its noise part is considered in PNI total. Now this expression of PNI total is something that we will use in one very important derivation that we are going to discuss immediately after this video clip.